I want to go over and review a little bit some of the translating and balancing, and hopefully this will help you guys with these challenges. Balancing is hard. It's new. We're learning. It's a struggle, and that's okay. So the first thing that I like to do is, I don't know about you guys, but I always forget to put my state scripts in my formula. And so what I like to do is I like to write them above the problem when I'm reading it. So the first word tells me solutions. So if you remember, solutions means it's aqueous. So solutions of a calcium hydroxide, which is going to be aqueous, and hydrogen nitrate, which is aqueous, react to produce liquid water and aqueous calcium nitrate. This way, when I check my equation when I'm done writing it, if I forgot to add the state scripts, I can go back and add them easily, and it reminds me to check for them. So now I need to put calcium hydroxide. And so calcium, if you remember, has a +2. Hydroxide is on my polyatomic ion sheet is a -1. So since calcium's a +2, that means I need 2 hydroxides to balance out the charge. Remember that this is aqueous. I almost forgot. Then I'm going to react it with hydrogen nitrate. Hydrogen is a +1. Nitrate is a -1. So those are already balanced as far as charges. I don't need to add any subscripts. I do need to put my state script, which is aqueous. Then it tells us that it reacts to produce water, which is a liquid, and aqueous calcium nitrate. So calcium, remember, was a +2. My nitrate was a -1. And so I'm going to need 2 nitrate to balance out my calcium. Oh no! Just trying to... Goodness. Right, my writing's just all over the place here, isn't it? There we go. I'm just trying to move over here so that I have a little bit more space. And so then 2, I need to check, and I forgot to put my aqueous state there. So there we go. Now I'm going to go back through and look. Everything's got states. Double check charges to make sure everything's okay. And then we're going to go ahead and balance. There are 2 ways that we can balance. I'm going to show you the way we've been doing first, and then we'll come back to the second way. So the first way is we're going to go through and write the different elements down. So I have calcium, I have oxygen, I have hydrogen, and I have nitrogen. I already have a hydrogen, so I don't need to add that one, and I already have an oxygen, so I don't need to add that one. So I have calcium, oxygen, hydrogen, and nitrogen. And so when I do this, now I need to count the number of particles I start with. And so for our counting, to start, I have 1 calcium there, so that's just going to be a 1. My oxygen, things start to get a little bit trickier. I have, this distributes to there, so I have 2 oxygen here, and I have 3 oxygen here. And so oxygen is going to be 2 plus 3, which is going to give me 5. My hydrogen, I'm going to do the same thing. I have 2 hydrogen there, and I have 1 hydrogen there for a total of 3 hydrogen. And then finally my nitrogen, I have 1 on my reactant side. On my product side, I still have 1 calcium. Oxygen, I have 1 plus 6 because my 2 distributes to my 3. So 1 plus 6 is going to be 7. Hydrogen, I have 2. Nitrogen, I have 2. So one suggestion is that when we look, let's first start and see what's not balanced. Well, things that aren't balanced are oxygen, hydrogen, and nitrogen. My calcium's already balanced, sweet. But these 3 things are not. When you're trying to decide what to start with something that is only in 1 compound. So for example, I'm not going to start by balancing my oxygen because if you look, oxygen is in every single compound that we have. And so that's going to be really difficult to balance if I'm bouncing back and forth. So I'm going to ignore oxygen for now. When I look at hydrogen, hydrogen is also in more than one thing at a time on one side of the equation. It's in both of those compounds. So I'm also going to ignore hydrogen for now. I'm going to focus on nitrogen because nitrogen is only present in one compound on each side of my reaction. So let's start with the simplest thing first. I know, we usually don't do that, right? We usually make things complicated and start there. I'm just going to neaten this up a little bit so we don't get things in the way. All right, so we're going to start by balancing our nitrogen. And so I noticed that on my reactant side, I need 2 nitrogen. So I'm going to put a 2 there. That gives me 2 nitrogen, but it also changes my hydrogen. So now my hydrogen is going to be remember I had 2 hydrogen at first, and now I've got 2 more hydrogen. So I'm going to go to 4 hydrogen because I had the 2 and now the 2. And it's also going to change my oxygen. Remember that oxygen, I have 2 here, and I used to have 3, but now I have 2 times 3, which is going to be 6 oxygen, plus the other 2, which is going to give me 8 oxygen. So now my nitrogen is balanced, but I notice that my hydrogen and my oxygen are not. So hydrogen is only in one spot over here. Here's my hydrogen and it's a 2. So I'm going to try to focus on that. I have 4 on my reactant side, and so my product side, to try to get that to go to 4, sorry, I had 4 on my reactant side. To get that to go to 4 on my product side, I'm going to need to put a 2 here, because 2 times 2 is going to get me 4. However, that also impacts my oxygen. So looking at the oxygen, I now have, once again, I'm just going to clean some stuff up to make this easier. I now have 2 times 1, which is going to be 2, and in my second compound, I have 2 times 3, which is 6. So 2 times 3 is 6, 2 times 1 is 2, 6 plus 2 is 8. So by focusing on the simple thing first, the one that had to be balanced first, it made that a lot easier. So what's the second way that we can do this? Well, glad you asked, even though you really didn't. I'm going to go ahead and just copy and paste down here so that I can show you. Oh man, I don't have another page. I lied to you. I'm just going to put it right here for now. And so when I put that there, I'm going to go ahead and get rid of all the stuff that I did before. Just bear with me for a second while I erase some stuff. All right. So if you understand the way I did before, feel free to skip this part so that it doesn't confuse you. So when we do this part, once again, we're going to write our calcium, our oxygen, our hydrogen. But now, if you notice, there's a nitrogen on both sides of the nitrate on both sides of the equation. And so, since the polyatomic ion is present on both sides, instead of separating those, we can write it as NO3. We cannot do that with our hydroxide because hydroxide is only in the reactant side and not on the product side. But since nitrogen is present in the reactants and the products, we can simplify things by just putting nitrate. Like I said, if that's going to confuse you, if you understand the last way, feel free to stay with that way, that's fine. For some people, simplifying it this way makes it easier. So whichever way is easier for you. Then we're going to count, and we've got the same things. We still start with the same amount of calcium. 1 calcium, 1 calcium. We have, now this time, because we're keeping nitrate separate, we're just going to focus on the oxygens that are not part of nitrate. So what that means is that in calcium hydroxide, I have 2 oxygens because I have 2 hydroxides. Then I'm going to focus on the hydrogens. And so my hydrogens, I've got 2 in the hydroxide and 1 in the hydrogen nitrate. So that's going to give me 3, just like before. And now instead of nitrogen alone, I'm looking at the nitrates. Well, the nitrate, I have 1 on my reactant side. On my product side, like I said, I already have 1 calcium. As far as the oxygen, I'm looking at the oxygen not involved in the nitrate, so that means I'm just looking at the oxygen in the water. My hydrogen, I have 2, and then my nitrate, I have 1. And so when I do this, now I can sit there and focus on balancing the other things. In this case, I lied to you, didn't I? I did lie to you. Those of you screaming at me through the screen. Over here I have 2 nitrates. I apologize. So I have 2 nitrates there. I'm not going to cross that out because you're going to think that I changed that. So I have 2 nitrates. So, just like before, I'm going to start balancing things by what's easiest. I'm not going to start with oxygen because even though oxygen is part of nitrate, it's still in everything. It makes it confusing. I don't want to pay attention to oxygen. The easiest thing to focus on is going to be the nitrate because it's unique. And so, once again, calcium nitrate, I have 2 nitrates. And so I'm going to come over here and put a 2 there so I can change my nitrate to a 2. Then what I'm going to do is I look at my hydrogen or my oxygen. You can go to either one, but I'm going to look at my hydrogen, and I notice that with my hydrogen, I have 3 hydrogen, nope, because I changed it when I changed my HNO3. So now my hydrogen, I have 2 hydrogen in my HNO3, I have 2 in my hydroxide, so that's going to change my hydrogen to a 4. In order to change that, I'm going to add a 2 in front here because on my product side I didn't have the proper amount of hydrogens. And so my hydrogens now, with 2 of them, are going to go to 4. And then the oxygen, 2 times 2 is also 4. So there are the 2 different ways that you can go ahead and balance equations. I think you can kind of obviously tell for whatever reason, I usually do the first way that I showed you. The second way, that's why I had to go back. I had some corrections to make as I was looking at some stuff. I had made mistakes. And so that's why is I usually do the first one. And so that's how you're going to see me do it in class. But if you understand it well enough that you want to keep the polyatomic ions as long as they appear on both sides, if you want to keep them together, that's fine.